Hello everyone, welcome to our very special lesson dedicated to space exploration, but in the context of polar regions, of course, and how the polar regions and in what ways polar regions can be actually a laboratory of space exploration. What is our purpose today? Today I'd like to tell you a little bit about space exploration, but it will be just a short introduction, and then we'll go to how we can use Earth to prepare ourselves for the space exploration itself. But also, two questions for you. What do you think? What is a main barrier, a main limitation that had to be overcome to start space travel in the first place? So, what made it happen? And the second question is for now, not for the beginnings of the space travel, but for nowadays. What's now limiting us the most? What do you think? In the meantime, I'll look at the poll. UV rays, I can see now, yes, as one of the limitations, dangerous radiation. Well, maybe not UV, not only UV radiation, but cosmic radiation. But what are two main barriers? What was the first problem that we had to overcome in the past? Resources. Yes, because especially if we take in mind, yes, fuel resources, fuel and energy in general. So this is more for the past, but also it's still limiting us. The energy and the supplies, money. Yes, it is very, very expensive to even plan a space program. Not to mention to organize an actual colony. For now, it's only in theory, a colony on another planet. Okay, so you got it right, but actually, in the very first place, we had to escape velocity. It means that we had to overcome gravity in the first place. So only in the second half of the 20th century, there were rockets developed that were powerful enough to overcome the force of gravity, and so that we are able to reach orbital velocities and to start space travel in the first place. Actually, as many technologies, it was possible thanks to Second World War, because Germany began to use those rockets as weapon, and they were developing, and as a result, we were able to escape gravity thanks to large velocity. But now there are many obstacles, of course, like you said, resources, energy, fuel, money, but the very physical limitation is the speed. It's the speed of light, which is the double the maximum speed that we can achieve with space travel ever. And so the speed of light and the distances between stars, they are so great that any trip to a star would take a lifetime, more than a lifetime for a crew. So it isn't possible to travel faster than light. And the energy required is so big. So the time is also the great limit that we have, that we don't live long enough to plan an expedition that one crew would be able to survive. Maybe you can remember the movie Interstellar, when there were theoretical wormholes that allowed to travel between dimensions, between time, basically. And it's actually for now, it's the only possibility to reach the farthest stars in other galaxies, for example. But we have a lot to explore still, a lot closer. So I mentioned the InSight probe, so the Mars exploration, and of course the Mars exploration didn't come out of nowhere. Nowadays we observe missions supported by NASA and planned by this guy, Elon Musk. He's a genius and entrepreneur from South Africa. You may remember what he did. It wasn't a long time ago. He sent a car into space. And it was widely observed around the world. And it was actually carrying a very special car, a Tesla electric car. Of course, it's not a human, it's a dummy. So this is how it looked like. Of course, it was a lot for publicity, but still, he's a serious entrepreneur and he's planning exploration of Mars. So humans have always looked up into the sky, dreamed about space. We're not going to go step by step by all those achievements, but like I said, the development of rockets, of ballistic missiles used in Germany at the end of World War II paved the way to launch some spaceship, and that was the beginning of a space race between Soviet Union and the United States. Some characters, some personalities that you should know, because this is the first man in space. So this round was won by Soviet Union. So this is Yuri Gagarin. Then we have the first woman in space in 1963. It was she was also sent by Soviet Union. Her name was Valentina Tereshkova. And then we have the very first man on the moon, whose name was, who's this guy? The very first man who set foot on the moon. Yeah, this was Neil Armstrong, exactly, during Apollo 11 mission. So this is a very, very brief history of space exploration, which is fascinating itself. But why do we even want to go to Mars? Because, or why do we even want to explore or even colonize Mars? Even though it's, like you said, it's very, very expensive. It's going to cost billions. They say that establishing, well, some scientists, even Stephen Hawking said that establishing colonies outside our planet, it's not an option. It's not something we do for fun. It's actually a necessity for survival of humanity. So, of course, it's very difficult to foresee for now how those human missions to Mars, not only probes, but actual humans going to Mars, that would cost hundreds of billions of dollars each, could benefit the mankind. Because it's easier to imagine that we can spend this money, these billions of dollars, and to immediately help the fight against cancer, world hunger. This is something that we feel that is closer to us and more necessary. So, but this is because we as humans tend to be quite short-sighted. So we're focused on what's happening today and tomorrow, and we're not focusing what's happening like 100 years from now. So Elon Musk, he is not short-sighted. He founded the space transport company, which is called SpaceX, to help make this happen. And actually, for colonization, Mars is the best available option because Venus and Mercury are way too hot to even allow us to be there or land there. And for example, the moon has no atmosphere, and when it has no atmosphere, it has no way to protect the residents of the Moon, from destructive meteor impacts. So we have no other option. Nearby, we have, if we want to go to another planet, we only have Mars. So there are many reasons to go to Mars, both political, economic, and many of them are quite intuitive, like we can grow as a species if we have a colony, if we have a backup Earth. We are ensuring the survival of our species. Of course, if we are able to transport lots of people from the Earth to the Mars one day, but who knows? Why not? Like in 100 or maybe in 1,000 years. This would also be a reason to improving the quality of life on Earth, thanks to some new discoveries. But some purely, maybe not purely scientific, but a very scientific reason is that we can actually discover life on Mars. Not those green, probably not those green men that we can imagine, but life outside Earth. And there is even a theory that says that we are all Martians. That means that all life actually comes from Mars. The theory says that at the early stage of development of Earth, of our planet, there were no chemicals that were very necessary to forming life. And probably Mars had them. And the Mars life theory suggests that there were rocks rich in microorganisms that could have been ejected from the planet's surface because of some powerful impact, and they were like tiny Noah's arks carrying those microorganisms, well protected, and they were making their way through the space to Earth. And it's not that impossible, because Martian rocks can be found on Earth. None of those that were found have shown signs of life for now, but who knows? There is a theory that we all come from Mars, that actually life didn't appear at first on Earth. And what is the reason to believe that? This is another probe sent by NASA to Mars. It's called Curiosity, a Curiosity rover. It detected some organic molecules in rocks on Mars. The rocks that are 3 billion years old, and those are sedimentary rocks, within 5 centimeters of the surface of Mars. So there is a possibility there was life, maybe not on the surface, but under the surface, and we'll get back to that because it's quite important too. But how can anyone be prepared for a mission like that? Well, there is no other way. We can only try and prepare ourselves during so-called Earth-based tests. So we have analog astronauts, and I want to show you that actually each one of you can become an analog astronaut. That is possible even for students, because we have some examples of Earth-based stations that serve as test stations for future space exploration, Mars exploration, Moon exploration. So these are the examples. The first one is from China. What is written here, it means lunar palace or moon palace in Chinese. In Chinese, it's something like Yekong. So you can see here 3 Chinese volunteers at the moment that they were ending an experiment. And the experiment was that in the station, Lunar Palace, they spent 105 days in an enclosed capsule. So this mission was concentrated on survival of humans in an isolated area without any external support. So they were eating only plants that they had laboratory grown, and they were also eating insects, and this was the source of protein for them. So this was the first mission that China prepared. It was the so-called Moon Palace 1. It's so-called bioregenerative life support base. Bioregenerative life support base or system. So BLSS, and the Chinese one is not the only one, it's actually the third in the world, is an ecological system that is of course artificial, and it is composed of some plants, animals, and also microorganisms. And what is important that everything, like not only water or food, but also oxygen, is recycled and regenerated in the system. So it is supposed to provide the astronauts who are still on Earth for now with an environment that is similar to the Earth surrounding them, but we're pretending we're on Mars. We have no access to external oxygen and so on. We have to produce everything by ourselves. So it's a loop, life support loop. You can see here that they were of course observed. It was divided into areas. So there was 58 square meters vegetation area and 42 square meters living area, like 3 bedrooms, dining room, bathroom, not very large one for 3 people, and also a waste disposal chamber. So, like I said, 105 days of self-sufficient life. What they had with them? Well, they had some stocks. So 45% of the food they consumed came from stocks, but the rest was produced on site. They had 5 types of grain crops. They had wheat, corn, soybeans, and something like that. 15 vegetables, carrots, cucumbers, and 1 fruit. And this 1 fruit was, would you guess? It was strawberries. They only had strawberries and fruit. And they had no meat, they had no cows, and the only source of animal protein was this. And these were worms, actually. They were eating this part. Not it was mealworms, yellow mealworms, but not this form, but this form. They couldn't waste anything, so the waste was also human waste. Was used for plant cultivation, a little bit like in this movie. I'm not sure if you watched it. It was a movie, Martian, with Matthew. Okay, I forgot now. But there was this movie that the guy ended up on Mars. All by himself because everyone else died. There was some kind of catastrophe, and he had to survive. And he was cultivating potatoes using waste, also his own human waste. But also, not only waste was recycled, but the air also. So carbon dioxide that was breathed out was used for photosynthesis. And air was coming back, clean air was coming back for breathing. So it was very, very efficient. But you know, like China has a space program, so you could imagine that, yeah, they have this kind of station. But actually, in Poland, we also have a space analog. It's called Lunares. It's in Piła. It's near, not a very giant city. It's near Piła, actually. And this is Lunares Research Base. Is specialized facility which is prepared to simulate space missions. It was created in 2017, so it's quite new, by a company named Space Garden. And this is the only facility of this type in Europe. And they conduct lots of different types of research, like not only how to survive with, how to produce food, but mostly human factors, like psychology during those space flights, that tests also of modern technologies, not only from space sector. So there's a company or a scientific institution, they can go there and test their technology in this very specific environment. So the facility is completely isolated from external environment. So there are buildings, but there are also 250 square meters of space for faked spacewalks. So they're faking to do some spacewalks. And the infrastructure allows to monitor health, behavior also, because psychology in an isolated group is a very important factor in space flights. And it is all monitored in this facility. So this is one of the groups. It can host permanently, not permanently, for a long time, it can host 6 analog astronauts. And this produces effects on mind and on body similar to those that are experienced in space. So yeah, this is one of the expert teams that was a part of it. Oh, okay. So this is what it looks like from the inside. It allows to work and live using like kitchen, some office modules. They also have an atomic shelter, fake atomic shelter. But also, like I said, 250 square meters of space to do fake external walks like they were doing in space. They are prepared for 2 types of missions: Mars and Moon. And this is an example of Spectra. It's a Moon mission. And this mission is supposed to take place in 2030, so they pretend it's 2030, and they went to the Moon, and they are situated in Lewin crater, and it's a very dark crater that, but it's very good for scientific research. So yeah, this is what they are tested. The behavior is tested, but also way of using some specific equipment. I'm sorry, I got something. Yeah. So, like I said, you can also be an astronaut, an analog astronaut at least, because in this Lunares site, there are also some educational activities that are conducted, and there was a group of young children, a school group, who spent there 3 days only, but they had all those clothes, they had to sleep there, and they had to conduct those researches, so they could feel they were isolated for 3 days, so they could feel actually as if they were actual astronauts. So yeah, what we have in those stations is here. So those groups are isolated. They can be conflicts in group, and especially if it's a long-term mission like this, 105 days. We can have some unknown reactions and problem with limited energy, food supplies, communication and transport. Well, it's all orchestrated like this. But could you think of a place on Earth when you experience the same thing, the same kind of problems with separation from families, communication, danger, lack of immediate medical help? Well, this all happens to scientists who live for a long time in a remote polar stations. So this is what they have in common, actually. They're both outer space and polar regions are definitely extreme environments. Well, space is probably more extreme, but they have some similarities. and they both still hide some secrets to reveal. There are lots of things that we still discover, like lately this great crater under Greenland. I don't know if you've heard. Well, there are still constantly new things that we find out about polar regions and space, of course. So this is what they have in common: human behavior in remote locations, and also some very specific equipment that could be tested in both those regions, in both those locations maybe. And the last thing I will share with you at the end is probability of having some isolated forms of life. So I'll come back to that. But of course, we cannot, for the moment, you cannot recreate everything that we have in the outer space. So what we don't have in those fake analog stations is like weightlessness and differences in gravity, because on Mars we have half normal gravity than Earth. It's much less gravity. So it's another problem or challenge. Of course, you mentioned that UV radiation is a problem for space travel. Well, in those analog stations, we do not recreate specific effects such as space radiations that can be. So this cannot be recreated, but well, this is close enough. We do what we can to prepare ourselves for those missions. But so I mentioned that polar regions and space exploration have a lot in common, so it had to be used. So polar regions had to be used for space exploration preparation, and we have very specific stations that are located in the Arctic and Antarctica. Actually. So the first one is based in the Arctic. It's a flashline Mars station managed by Mars Society in cooperation with NASA. So where is it located? It's in Canadian Arctic, and it's supposed to simulate Martian environment. So we are on Mars. And there are lots of types of research, like planetological research, testing of equipment, and so on and so on. Actually, it's on an island, Devon Island, in a polar desert, which is the largest non-inhabited island in the world. It's totally uninhabited, except for those who live at the station. So we have this Devon Island with this crater, and the ultimate goal of this station is to support actual training for those who will go to Mars, or those astronauts. So they are testing lots of types of new equipment. You can see here they behave as if they were in space. We look at what they have on their heads, for example. If you want to test something, like you produce a new type of spacesuit, well, if you have a test, you can wear it for 2 minutes. It's one thing, but another thing is it's much more beneficial to use it in actual field work for 2 months maybe. So this is why it is very, very important to have this kind of almost real-life stations. Well, they are not very big. They like containers like this. Well, maybe if you look at the picture, they're pretending to be in the outer space, but actually they have quite normal shoes, so it's not 100% recreated. But they're doing what is called EVA simulation, and EVA is short for extravehicular activities. So if an astronaut goes out of the vehicle on Mars and needs to collect samples, it's called EVA, extravehicular activity. So they need to be prepared for that. So they're testing their space suits and so on and so on. But shoes, well, they're probably not testing shoes for now. So this was Canadian Arctic, but of course in the south it is also used. Well, if we're in the south, and the closest who would like to conduct some research there are Australians. So they are using Antarctica, and actually for a very long time, because this station, Australian National Antarctic Research Expeditions, began in 1947, so really a long time ago. It's so-called ANARE, Australian National Antarctic Research Expeditions, and it also is conducted in cooperation with NASA. So you can see it was started here in 1947, and actually there were, here you can see some first women explorers who were allowed to go to Antarctic. And Antarctic is unique, and in a way more unique than Arctic, because there are no humans. In the Arctic we have lots of humans, but actually there were no humans until the beginning of the 20th century. And there is no permanent civilization, so there are only visitors. And even though we have this modern technology, Antarctic remains hostile, dangerous, unfamiliar environment. There is a lot of physical isolation, much more than in the Arctic. It is very, very cold, and well, it is most extreme and the most isolated on Earth. So people are totally dependent on technology there. So it was used to construct this station, ANARE, which was, here you can see Antarctic and this Macquarie Island. And there was actually, they were focused on medical research for 50 years. So as a result, they were researching medical effects of being in such environment, in confinement, in physical isolation, also in cold. So yeah, this is what it looks like. This Macquarie Island, this ANARE station, and what they found is that we observe certain effects if people are exposed to some stress, very long-term and very specific stress. Like it has immunosuppressive effects. That means it can cause some diseases, some sicknesses, infections, allergies, even cancer and autoimmune disorders. They were all more probable because of long-term being there. I also mentioned that well, permanent stations are one thing, but polar regions are also used for testing some research equipment, and the research equipment that could be also used in the space during space exploration. Here we see a camper, which is camera and samplers, and here we can see agave, where a special kind of robot. And actually this one is very interesting because it was designed to study volcanic activity at the bottom of Arctic Ocean. And actually it proves that there is an actual activity of volcanoes erupting very violently, even though the scientists thought it was not possible because of the extreme pressure. But the use of it doesn't end here, and it is thought to be used, for example, on the ice-covered ocean on Jupiter's moon, called Europa. So it is tested in polar region, and then it can be used for outer space research, because the conditions are actually quite similar. And last thing I'd like to share with you is that the one thing is that we're testing things, checking out how people behave in isolated conditions for a long time, how equipment works, how it is how you can provide energy, fuel, and food, or even grow food in in this kind of station. Remember, they survived 105 days without an external supply. So we already use some aquaponics in stations, well, to grow food, to grow fresh vegetable, but still for now we're based in regular station, we're mostly based on what we bring with us, for example in Polish Polar Station Hornsund. But in those kind of stations you need to, in some of them, you need to provide food or even oxygen, as you could see, for yourself. So, but another thing is that what we can find in polar regions can be very interesting and can allow us to trace life in space. Because universe in general is a very, very cold place. That's why I called it dark, cold Eden. And most of the water that exists in the universe exists in a solid state rather than a liquid state. So it's actually more ice than water. But on Earth, liquid water seems to be essential for the existence of life. And luckily, we're lucky enough, our planet has the right temperature, and we have liquid ocean, hydrological cycles, so life here in the form that we know is possible. There were some other oceans of liquid water that were discovered in our system, at least in our solar system. Mostly I mentioned this moon of Jupiter, Europa, also Enceladus. And probably we think that maybe beneath the permafrost layers on Mars, they can be liquid water. But testing and research conducted in very extreme environments allows us to follow the life in like the limits. What is the minimum that life needs to thrive? Well, there was actually some sampling. Well, there are two things. Remember this photo. This is in the Antarctic. This is called blood falls. They look a little creepy, like they're bleeding actually, but this is liquid water with bacteria and with iron that's coming out of the glacier. And yeah. What was discovered, like the most extreme, the most extreme environment that you can imagine is Lake Vida. Lake Vida is the almost completely frozen lake within Antarctica dry valley. So it's frozen and it's dry. It's a desert outside. It's very dark. It's very salty. And the water actually, because of the pressure, is not 0 Celsius degrees. It's minus 13.5 Celsius degrees. So we dug down to an area when there were through 20 meters of ice. So it was very salty. This brine, this means salt and water, is 6 times saltier than seawater. There is little oxygen, but there's lots of nitrous oxide, which means this water is basically acidic. It's like acid. No sunlight penetrating, and water temperature, because of the pressure, minus 13.5 Celsius degrees, and it was isolated for 3,000 years. So you'd expect no life in there, but actually in those hypersaline, hypercold conditions, they found this. They found bacteria. So they probably had no contact with outer environment for 3,000 years at least. So what does it mean? It means that we can, in those kind of conditions which are very similar to outer space, we can find life. And maybe if we cannot find life on the surface of Mars, there is life under thick layers of permafrost on Mars. So this is what it is. And another thing is, we know that if something is isolated, it can develop in a totally different direction than the rest. So we know that we know life in the form more or less that is similar. Even bacteria, plants, fungi, even us, we function more or less the same way. But what if life, a different form of life, developed in total isolation? Well, that would be something that we cannot even imagine, and probably this is what we're going to find on Mars. So thank you very much for your attention.